Alright, so in this example we're going to look at how to find the composition of trig functions, and we're going to give the exact value of the expression. And so what we need to notice is that we have the inverse tangent of the tangent of 6 pi over 7. Recall that an inverse trig function is equal to some angle theta, and then I can bring the inverse tangent to the other side, and what that will give me is tangent of 6 pi over 7 is equal to tangent of theta. And that means that theta would have to be 6 pi over 7 if that angle is within bounds. So the restrictions on the inverse tangent function say that theta has to be between negative pi over 2 and pi over 2. So the question is 6 pi over 7 in this range? And the answer is no. 6 pi over 7 is a second quadrant angle. So what we're going to do is we're going to draw a unit circle to find theta. So 6 pi over 7 would be in the second quadrant, and we know that that angle is 1 pi over 7 away from pi. So we've got 6 pi over 7 to this angle here, and another 1/7 would make 7/7, which is a pi. So notice that we need for the tangent, inverse tangent, to be in the range from negative pi over 2 to pi over 2. And we know that 6 pi over 7 is going to produce a negative value for tangent. And so that eliminates quadrant 1, because quadrant 1 would produce a positive value for tangent. So our only option is that we need an equivalent angle to be in quadrant 4. And if our values are restricted to be between negative pi over 2 and pi over 2, and this angle in quadrant 4 has to be equivalent to this angle in quadrant 2, that means the angle we're looking for must be negative pi over 7. So the answer to the problem is theta equals negative pi over 7.